Okay, we will start. Others will join in the meantime. Uh, Vishwajit, am I audible? Vishwajit Mankar.
Voice is cracking.
Yes, yes. Yeah, slight delay due to some internet issue, but I think it will get resolved. Vishwajit, am I audible? Mhm. So, yesterday we have finished with the nomenclature and the symbols used for the low cost automation. Especially these were the components which we normally aware that these are all mechanical components, and the medium that is used to actuate these most of these elements or components is air. So that is why low cost automation is heavily dependent on the pneumatic system. Yes, nowadays there is lot of development and other let's say electrical actuation is also there. So electro pneumatic systems are more popular nowadays. Then they are having some programmable aspects also, so with that you can actually program, so for that you need computers also. So these extensions are there. Later on we will see about it, but now we will start with the basic circuits for the LCA low cost automation, purely for the timing, purely using mechanical components. Now, what we have seen earlier, that is there are valves and there are actuators. Suppose now you want to actuate one particular cylinder, it may be single acting cylinder or double acting cylinder. So how will you actuate that single acting cylinder or double acting cylinder? So now, as I told you, there are a lot of combinations possible. When actually students were there in the campus, we used to conduct the experiments. I have given freedom to students that whatever circuit they want to form. So there was no fixed setups as such that I want circuit for like this only. So it is dependent on your creativity what kind of circuit you want to form, because then and then only you will be able to understand. Otherwise, simply if it is told that see these walls should be there, this cylinder should be there, then there is no flexibility. Like you can prepare, suppose one software program is there. So different people can think in different way and they can have different logic. So similarly here, for LCA circuits, you can form for the same application, for the same outcome, you can design different circuits. So to start with, we will see the first very basic and very simple circuits to actuate some of the reciprocating actuators. Okay, so first circuit is, so this is the first circuit. So this first circuit is 2 by 2 wall actuator control. So now what is the meaning of this? Simple thing is that they have used 2 by 2 wall. 2 by 2 wall means what? Always try to remember this nomenclature, that is it is the wall having two ports and two positions. So that is what first digit will indicate the ports, second digit will indicate the positions. So currently we are having the circuit for two port two position wall. This wall now that different thing I would like to leave it to you. Right now they are selecting this single acting cylinder. I would also like you people to think, suppose you are replacing this single acting with the double acting, so what connections will be possible? That thing we will have later on. At least some practical part will be there once we cover some basic circuits. So one of those basic circuit, if you are able to form on the simulation software, then it will be very easier for you to understand. So pair of most basic of wall types, that is 2 by 2, can be used to control a single acting cylinder. Now what assumptions are there? First assumption is that it is a normally closed position produced by the spring. It means what? The current position that you are observing, spring is expanded, it is inbuilt spring. So piston is at the left extreme position. So with that, there is, you can see, um, normally closed position. That is in stroke position is there for the piston cylinder. So if that is the scenario, you can find out then in the operated position produced by the push button, means you will apply pressure to the push button. So in that case, air will be supplied to the cylinder. One wall admits the air, other wall exhausts it. In the present position, that is in stroke position, you can see both the walls are in shut off position. There is no supply of air. But if you see the other square position, in that the first wall that is indicated with the out, another wall indicated with the in. So that out wall will supply air, arrow is indicated over there with the application of pressure to the push button. So obviously air will be supplied and outstroke will be there for the cylinder. Then once the outstroke is there, it has completed the stroke. Once you release the pressure from the push button, then with the spring force, it will come back to the original position. So in that case, there will be exhaust of the trapped air. That exhaust will be provided by another wall, that is in wall. So this is how simple operation is possible for this 2 by 2 wall. Now there are a lot of things which can be possible for such circuit. This is where actually your flexibility will be there. That is, you can think to make this particular circuit more effective, more flexible to respond to various conditions. What can be done to make it more flexible? That if some of you can suggest, it will be better, because that is where your creativity you can apply. But firstly, have you understood the functioning of this 2 by 2 wall? It is very easy. The symbols, the airflow that is taking place from one port to another port. Now these are basic circuit. Using these basic circuits, further complicated circuits you can form to have different complicated applications later on. Is it understood? ये कौन है?
So,
empty understood or not? हाँ, yes, Aditi.
so could you please repeat the functioning of this 2 by 2 valve?
Okay. Yes, but empty understood or not? empty है, फिर कौन है? ये SK है, कोई तो भी NS है. These people understood or not? People staying in darkness, understood or not? empty कौन है? SK, NS है कि नहीं? ये लोग इधर कि सच में डार्कनेस में है ये लोग? MT stands for Manas Thorat, NA stands for Nishant. Uh, His further name is not there. SK stands for Shubham. Are you there or not?
Yes, sir, I'm
हाँ.
there.
तो ये कहाँ पर डार्कनेस में जाके बैठ रहे हो तुम लोग? No reply at all. So okay, Aditya, I will repeat it again. Okay, I will try to explain this. But if still you people don't understand, then I will try to run one video. A very small video is there, probably with actual simulation. You may be able to imagine it better way. Right now, I will try to explain. As the position which is indicated over there. So what is the position? In this position, you can see out wall 1 to 2 port they want to connect, but it is shown in the shut off position. Shut off position, why? Because the spring has expanded and it has now further stroke will not be possible. So it will remain in shut off position. Then in the similar situation, exhaust is also shut off because there is exhaust has already occurred. There is no air trap now. So it will remain on shut off. Now what happened next? You are pressing the push button. Whenever you are pressing the push button, that is the another square. You people can observe, suppose now out wall is indicated, there is another square which is not connected right now, but once you press the push button, it gets connected. It gets connected means what? Air will flow as shown by the arrow. So air will flow from 1 to 2. Once air flows over there, so that is air pressure will be applied to the piston and outstroke will occur. Spring will get compressed, outstroke will occur. Now, in this process, outstroke occurs means what? From the other end, exhaust also occurs because air trap gets exhausted, or it is simple terms we can call it as vented out to the atmosphere. In that case, square of in wall, in which reverse arrow is indicated, that arrow is indicating the exhaust position. So that position occurs when you are releasing the push button. You have pressed the push button, pressure is applied. Now you are releasing the push button. Again, spring is expanded, and whatever remaining air is there, that also get exhausted through the another wall. So this is the scenario. That is what happens over there. So these two positions are possible. That is why two squares are indicated over it. And two ports means 1 and 2. So these two ports are there. That is why we call it as 2 by 2 wall. And with this wall, you can actuate the single acting cylinder. Aditi, is it clear now?
So could you use the cursor while referring to the diagram? Because it's becoming a little difficult
What?
to visualize what you're saying. So
Yes.
could you use the
What did you say?
mouse pointer while referring to the diagram because
Acha,
it
acha.
becomes very difficult to visualize what you're saying.
Okay. Or can I show you people one simulation? So
Yes, sir, yes.
simulation, I will just try to get it from there. Actually, I wanted to show you all those simulation. There are some 6-7 videos. I wanted it to show you at the time of practical. But if right now you are see what happens when earlier you people were there in the campus, means students used to come over there. So these all things they used to do on their own. This is highly practical subject. It is not theoretical, means just observing diagrams. It really becomes difficult to imagine because how these walls get actuated, how the position gets changed. Since you have not done so far, so it is difficult to imagine. So they used to do it on the software as well as on the anybody has tried to download that software, fluid sim software. 5.6 version, it will be easier for all of you to understand. Anybody tried or not? Okay, then you can try in between. Um, I will try to show you one video so that at least you will get some idea how it is performing. Some net issue is there. Just wait one minute. I got it, but Okay, I will play that video just now.
On the Festo pneumatics equipment, the simulation of our pneumatic
circuit. We're placing a compressor symbol from our library of components. Now we're putting in our filter and gauge or our air service unit. Now
So,
control valves, which will control our cylinder.
Is it visible right now?
so could you just send it to the CR on WhatsApp so that we can see it because it's not visible.
In this case, we're going to have a
Okay, that also I will do.
detent
Let it finish now.
in position.
So, but we can't see the video.
And our next valve is also going to be a 3 two-way valve. But in this case, we'll be using a push button rather than the detent and a spring return. So I select the spring option and our symbol changes to reflect the spring attached to the valve.
Now we connect our ports using a valve. We can adjust the properties which will control our cylinder.
And then we're putting in our pneumatics equipment.
Those practicals using the Festo Fluid Sim software to create a simulation of our pneumatic circuit. Placing our compressor symbol from our library of components. Now we're putting in our filter and gauge or our air service unit. And then we're putting in our cylinder, which is a single acting spring return. We can move our components around to set the layout of the circuit. Now we're putting
I have put the link in the classroom also. Stream.
which will control our cylinder. This is a 3 two-way valve. By right-clicking on our valve, we can adjust the properties of the valve. So in this case, we're going to have a push button with a detent, which holds it in position. And our next valve is also going to be a 3 two-way valve. But in this case, we'll be using a push button rather than the detent. And a spring return. So I select the spring option. And our symbol changes to reflect the spring attached to the valve. Now we connect our ports using a line drawing function, which would simulate our pneumatic hosing in our real circuit we'll be looking at in a minute. Once we've connected the hoses or the lines, we can then simulate the operation of the circuit using an animation function by just pressing the play button. We get a warning message about our open connections, which are not going to affect the circuit in this particular case. We see the dark blue line, which indicates the air pressure, and the light blue means no air pressure. By pushing the button, we then get pressure supplied to the cylinder, and the cylinder moves. Do that for real on our Festo boards in the lab. We've got an air supply unit here with a pressure regulator, filter, pressure gauge. We've got another pressure gauge here, a single acting cylinder, a three-two-way valve, another three-two-way valve, which is our supply on-off, and a manifold to distribute our air supply. We're going to be using this pneumatic hose to connect up our circuit. And I'll do that now. So we're just pushing the hosing, taking note of the port numbering, which should match our simulation that we had on the computer. And our pressure gauge here will give us an indication when we've got air supply into the cylinder. So now if I connect it, I'll switch on the supply. And if I press this button, nothing happens. But if I turn on our master supply here, press the button, we get the cylinder extend and air pressure shown here, which then drops. And this is a spring return cylinder, so that's the cylinder back. If I switch this master control off, cylinder now does not operate.
Okay, Aditi, did you understand now something, at least how that actuation takes place? Aditi, are you there?
Yes, sir.
Understood to some extent?
Yes, sir.
Okay, see, this video means the setup which they have used, it is the same setup which we are having at our lab. And students used to do the practicals on the same setup. So you could have seen there over there. That is on that board. You can assemble any circuit over there, and you can use any combination. You want, suppose I want 3x2 wall to achieve the single acting, so that you can try whether it works or not. You will learn from that. If someone says no, I want to use 2x2 wall, so that is how he can connect. So these all combinations were possible. Right now they have shown in the software. The initial part of the video indicated the software. It is the same software which I told you people that you can download. Any version you can download. Whatever is compatible to your system, and it is the same thing you will have to do. That is, you can drag on the blank space over there, and then you connect those components. You try to simulate it, then you, probably you will be able to do all those circuits. Okay, so now this is the scenario. This is how things can be done. But I think if you people want some more things, I can share with you some other videos, so that if it is getting slightly difficult for you to understand, I can play some. These videos are not very large,
Okay,
say 20 to 25 minutes. So I can
Yes.
play those, and
Yes.
then so then I can move ahead, so that later on you will not be having any confusion, because stepwise videos I have selected. And in some of the videos, very good color combination is being used for inlet, outlet, like that. And then most importantly, all this constitutes real-time application. Now, okay, this circuit we are thinking in isolation, 2x2 actuator, like, okay, how will you use in the practice, where it is used in the practice? So for that also, one minute videos are there, that is real, all your gear changing operations, some other brake operations, a whole lot of operations, you can use all these circuits, how to use that. So for that, very small videos are there of say 1 minute videos are there. So I think I can play before moving ahead. If you don't understand, simply explaining, if you don't understand it, there is no meaning, just moving ahead. So I will try to play some of those videos.
The second example uses a double-acting actuator. When the button is pressed,
Can you see
the
it?
back of the cylinder pushing it out. But this time, when
Yes, sir.
the button is released, air is sent to the front of the cylinder, pushing it back, relying on a spring. Air is exhausted through different ports depending on the position of the cylinder. Best practice would see unidirectional flow regulators to ensure that maximum flow is allowed into the cylinder, but flow is controlled when in the exhaust phase on each side. The second example uses a double-acting actuator. When the button is pressed, air is sent to the back of the cylinder, pushing it out. But this time, when the button is released, air is sent to the front of the cylinder, pushing it back, rather than relying on a spring. Air is exhausted through different ports depending on the position of the cylinder. Best practice would see unidirectional flow regulators to ensure that maximum flow is allowed into the cylinder, but flow is controlled when in the exhaust phase on each side.
Okay, the next one I will play.
In this video, we'll try. Try to understand how the simple pneumatic circuit works. So let us start with the pneumatic circuit to operate a single acting cylinder. So first we'll draw the circuit over here. So we have shown the FRL unit over here and then the directional control valve. So as you can see over here, high pressure air from the compressor, it enters into the FRL unit, that is the filter, regulator and lubricator unit, where air is filtered, regulated and lubricated, and then it enters into this particular direction control valve. So here we have shown the push button operated and spring offset three-way, two-position direction control valve. So three-way, they stand for ports P, R and 1. This is a three-way, and two position stands for this left envelope mode, and this is right envelope mode, and this is the push button. In this particular position, we are having this particular right envelope mode, and because of this particular spring force, the piston along with this piston rod is retracted, and the air from this particular side enters into the port 2, and from port 2 to port 1, and then it will be going to the atmosphere. Now we'll see the animation, with the help of animation, how this particular left envelope mode will work. So when the push button is operated, we'll be in the left envelope mode. So as you can see over here, now the air from compressor, high pressure air from the compressor, it will enter into FRL unit from this to port P, from port P to port 1, and then from port 1 to port 2. And then the air pressure will accessing the spring which is there. This port R is blocked. So in this air is admitted only on the one side of the piston. Therefore, it is known as single acting cylinder. Now let us try to understand the working of double acting cylinder. So first we'll draw the circuit over here. So this is the FRL unit, as we have already seen. This is the direction control valve. And this is the double acting cylinder. Now let us try to understand the working for this particular right envelope mode which we have shown over here. So air from high pressure air from compressor, it enters into FRL unit. Then from this it will enter into the port P. From port P it will go to the port 2. From port 2 it will be admitted on the port 4, and it will cause the piston to return. The air from the other side will, from port 3 it will come to port 1, and then from port 1 to R, and then it is exhausted to the atmosphere. When we press this particular push button, then this particular animation, how it will be working. Now, as shown over here, this is four-way. So four ways are nothing but P, R, 1 and 2. So these are the four ports which are there. Two positions stands for this left envelope mode as well as this right envelope mode. Now let us see what will happen. We push this particular push button. So when we push, we are in the left envelope mode. And now the air from the compressor the piston to move forward, and air from the other side, that is the rod inside. From port 4, it will enter into port 2. And working of double acting cylinder is there.
Okay, I think we can stop here today. Actually, few more are remaining, but next time we will continue from there.
Okay, sir.
Up to what? Yes, yes. 3 videos I have shown or 2 videos. Okay, YDC. Okay, fine. So we will stop here today. Next time I will have. If you people need to see videos, then firstly I will complete that, and then explanation will start. Yes, yes. I can upload it into the classroom, but I want to see you in one proper sequence. If you skip the sequence, then probably you will not be able to understand it. Okay, so I will do it in one word file. I will copy all these links, and that word file I will post. So from top to bottom, you can see the videos in that particular sequence. Okay. So I think we will stop
Okay,
here
sir.
today. I
Thank you,
will
sir.
just
Thank you, sir.
Thank you, sir.
Thank you, sir.